let me show you what we have in Google Classroom for the week. All right. So looking in Google Classroom, if we go over to our classwork tab, this is week 8. We're almost at the end of the first 9 weeks. Week 8. Here's our lesson for today. We're going to be going over the stuff in our lesson shortly. Here's our activity we're about to do in class. So if you want to go ahead and click and log on to that, you can. But here's our assignments for the week. We have lessons 8 and 9. That's informative. And we also have our first College Board assignment. You know, I said up here, I've left this at the top. You have to create a College Board account. We did that like way back in September, maybe even in August. Make sure you create a College Board account. There's directions on how to do it if you have not. And then here's our class code for third hour. So you got to have create your College Board account. You log in, go to join a course, and that's the code to join if you've not joined our third hour class. So that again is all right here in Google Classroom at the top. And this is our first assignment there. So when you click on this link, it'll take you to the College Board website where you need to make sure you log in, and it will take you, it's like 10 multiple choice questions. So 10 multiple choice questions. And it's basically over everything we've studied up to this point. So you have that, and then our lesson 8 and 9 informative. That is the assignments this week, those 2 items. So let's look at our lesson for today and what we're going to be talking about. So I'm going to start with this. All right, in Algebra 1, you learned that a linear function has a constant rate of change, right? And a constant rate of change can be seen as the slope of the line on its graph. So now we're going to consider different situations that are linear or nonlinear and evaluate whether rates of change over certain intervals could be described as positive, negative, or constant. All right, so here's 3 questions I want to consider. What is the relationship between the rate of change of a linear function and the slope of its associated line? So if we have a linear function, I am knocking all my medicine in the floor. That's not good. If we have a linear function, how does that relate, the rate of change of that function and the slope of its line on the graph? How does that relationship? Any thoughts on that? If you have a linear function and we're talking about the rate of change, how does that compare to the slope when we graph that function? A lot of thinking going on. It's the same thing. The rate of change is the same thing as the slope on a graph. How much the linear function changes. Every time the x goes up 1, how much does the y change? That's the same thing as the slope. So if a function is linear, what is true about its rate of change? If it is a line, if it's linear, what is true about its rate of change? I can give a hint on this one because we already mentioned it. If I had a opportunity to give a hint on that, I might do that.
The constant rate of change.
Constant. That's right. For a line, the rate of change is always constant. It's always +3, +3, +3, +3, or -4, -4. You know, it's always the same constant rate of change for a linear. Now, here's almost a trick question. If a function is constant, what's true about its rate of change? Oh, what does it mean if a function is constant? Function is constant. Let's look at this little box right beneath there. A constant function has the form of f of x equals a, which a is just a number. So it'd be like y equals 2. That's a constant function. Y equals -3, y equals 0, y equals 7. That's a constant function. And when we graph that, that's just a horizontal line. That's a constant function. So its rate of change is 0 because it doesn't go up or down. Every time the x changes, the y does not change at all. It's the same y all the way across. If this is y equal 1, the y is 1 all the time. on the lesson, I do have those answers down at the bottom page. If you're reading this lesson again later, we got the answers to that. But now I want us to go to this Desmos activity. So I want you to go to Google Classroom and go to this Desmos activity for class in week 8 and click on the link. And it should take you to a page that looks like this. You might have to log in first. I'm already logged in to Desmos. So use your school account, your Google. If you're not already logged in. All right. I see Daniel's in there. Go to the Desmos activity in Google Classroom. There's Cadence. And let's go to the activity. There's Brayson. First thing you'll see is it's got 3 sets of cards. Well, it's got, what we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cards, and they want you to divide them into 3 different sets. Your cards should be broken into a positive rate of change, a negative rate of change, or a constant rate of change. So put them in groups together. Put them in groups together based on whether they're positive rate of change and negative rate of change or constant rate of change. Some of you haven't got there yet. If you're just joining us, we went to Google Classroom to the Desmos activity. The Desmos activity in Google Classroom. Desmos activity. Log in with your school Google account. You probably need to be on your Chromebook or a computer to do this. I don't think it'll let you log in on your phone. Let's see if you can group them in 3 different sets. Let's see, I'm going to start working on some of mine here. Let's see. I'm going to put one up here. The change in height of a girl from age 19 to 20.
Okay.
I almost think that's a trick question because sometimes girls have stopped growing by that age and sometimes they're still positive. I'm gonna say that's probably constant. I'll bet it hadn't changed much. Now the change in height of a girl from age 4 to 5, I'm gonna put that over in my positive. Let's see, distance travel. I'm gonna group those together. Okay.
Here's my question.
Distance traveled, that's definitely a positive. How you guys doing? You getting this?
How much more do you
So I want to say, let's see, that's a constant rate of change over there. So I'm going to say that girl from 19 to 20 is probably constant. Some of you guys are about done with it already. Yeah, you can link them together, guys. So when you sort them out there, link them together. If you put one on top of the other, it'll show a little blue bar. That means you're linking those in the same group. So Brayson, make sure you're putting yours on top of each other to where they're linking them in the same group. Okay. Let's see, the change in the number of guests in the amusement park over the first hour. Okay, well, that I expect would be positive. That'd be growing. Let's see, that one's a negative slope. So that's a negative rate of change. This is a negative rate of change. See, this one, move that up. This is a growing positive slope. So that's positive rate of change. Let's see, the change in temperature of a liquid in a cup of hot chocolate left on the counter in the first 30 minutes after it's poured. Well, it's not going to be going up. The temperature, the change in temperature is going to be going down. It's not going to be constant either. We know it's going to be getting colder. And the change in number of guests in the amusement park during the last hour. Well, the last hour, everybody's starting to leave. So I'm going to put that over here too. All right, there's what I believe mine are.
get? 'Cause you're like, you're the answer. 'Cause 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 you're the answer
Interesting. I'm looking at what Desmos says is correct, and apparently this middle group I have, it does not think is correct. It says that's a common incorrect group. Interesting. So let's see. The rate of change is a negative. That's a negative. This has to be a negative. And the change in the number of guests at the amusement park during the last hour of the day, well, that's when people are going home. So the number of guests has to be going down. I don't see where anything would be wrong there. Says this first group doesn't like something in there too. If I took this out of the group, does it still say that's an incorrect group? Huh. Oh, I see what I've done. Okay. This is a negative slope, but it's a constant rate of change. It's a line. That's going to be over here. And this is probably a constant rate of change in that first. Well, I can't get it out of there. Because it's going up 30 every time here. So that's going to be a constant rate of change. Let's look at. Oh. I don't know. It's still got different things. It says is right and wrong, but you can argue it. Probably give it to you. This is a negative rate of change. It's changing more and more negative. We know this is going colder and colder. The number of guests has to be negative. Exponentially negative at the end of the day. Now let's look at the next page. Everybody got that? Everybody done on those? Okay, let's look at the second page here. Identify at least two pieces of the graph. There's the graph on the right, over which the height of the tide is increasing. Highlight those sections of the graph in green. All right, so we're supposed to use green. That is the pencil eraser. All right, so pencil, and they want it to be in green. So I'm in green right there. Okay. So they want to know, when is the height of the tide increasing? All right, so be putting that on there. Here's the height of the tide on this table of it, this graph over here. It goes from the height relative the feet relative to the something, MLLH, and the date. So it goes a little over 6 feet down to just about zero, just a touch under zero. So you should be highlighting in green at least two places where it's increasing. The tide is increasing. The water's level is going up. So I'm going to do one of them myself here. Okay, right there. So that one's going up. There's a low point right there, and it's going up. There's two. You gotta have at least two. In the box, explain what you know about the rate of change of the tide's height for the pieces you highlighted. The rate of change is positive. I know that. And increasing. Actually, towards the top of that, it's got the rate of change is decreasing. But certainly the, I could say the average rate of change is positive and increasing. All right, if you get done with that page, let's go to page 3. Same chart. Okay, this graph, they want us to identify at least 2 pieces where the height is decreasing and do that in red. So they want us in red for wherever you see the tide decreasing. So back here, we had the green for the increasing, for the height of the tide was increasing. And then they went red where it's decreasing. So, all right, so that should be right there. The lots of decreasing. And what do we know about the change of the tide's height? The rate of change of the tide's height? Yeah, it is negative, right? The rate of change is a negative rate of change. Absolutely. And we certainly know the average rate of change is decreasing, going down. All right, share with class. There we go. All right, let's look at number 4. This graph shows the height of the tide in California over the course of 3 days, just like the other 2, same one. Now we're supposed to look at any places where the height of the tide seems to stay the same. Highlight those in purple. So in purple, any places where the tide is not going up, the tide's not going down, the tide is staying the same level. So there's a few places we can see this. When it gets to the bottom, it's at the same level briefly there, not for a long period of time. It briefly stays the same there for a few minutes. We have a few places where it stays the same. So any of those places along there, we're going to see the tide's not increasing or decreasing at those points. They're just staying the same. And that's usually a transition, right? It's the tide is getting higher and higher, then it stays the same for a few minutes, and then it starts going lower again. That's where it switches from one to the other. The rate of change is constant. Oh, at 0. Yeah, the rate of change is 0 at those points right there. And some of the days are pretty close to the same day it was before. Sometimes the high tide's a little different, but it's close. But then the rate of change is 0 for those few minutes each day, each time. All right, what is number 5 want us to look at? All right, now we got a marathon. Karen runs a marathon. Here's a graph of her distance. Okay, this is distance from the starting line in miles. And the times at the bottom. 1 hour, 2 hour, 3 hour. It looks like it took her between 6 and 7 hours. And she ran between 24 and 27. We know it's like 26.2 or something, right, as a marathon. Complete the table of values with the approximate endpoint value for each interval. So I'm going to start with hour 0, 1, 2, 3, 4, 5, 6. You can start with 1 if you want to, your choice. I did 0 through 6. So how far away was she at time 0? 0. She had just starting, right? So at 1 mile, where's it look like she's at 1 mile? Put that in your table. I mean, at 1 hour, not 1 mile. I'm sorry. Distance At 1 hour, it looks like she is 6 miles away. Then at 2 hours, she's at 9 miles away. At 3 hours, 12 miles. 4 hours, 18 miles. 5 hours, I've got to kind of guess. Kind of looks like 20. And then at 6 hours, she's right at 24. She's moving on down the road. All right. So the next page runs a marathon. Here's a graph of her distance from the starting line, the time she ran. Determine the interval over which she was running the fastest. Which one of those, A, B, C, D, E, F, is she running the fastest? Well, we know it's not interval E because apparently she sat down and took a break. Went to the bathroom or something. I don't know, but 4 hours, she stopped running for a half an hour or so. Also at C, she took a lot of breaks here, didn't she? She took an hour off. But which interval was she running the fastest? In other words, which one has the largest slope? Right? Which Y changed the fastest compared to which X's? I can see an argument for a couple of correct answers. I mean, we know obviously A is running faster than B. Because in B, during that 1 hour, she only ran 3 miles. But during this 1 hour, she ran 6 miles. So her slope is 6 miles an hour, where this is only 3 miles an hour. And then 0 miles an hour, 0 miles an hour here. Let's see. D looks steeper than F, so F would be a smaller slope than D. But what is D? D is an hour and a half. All right, hour and a half. And she ran how far? From 9 to 18. So an hour and a half, 9 miles. That's also 6 miles an hour. I think A or D at 6 miles per hour. F was about 2 hours and about 9 miles in 2 hours. So that would be less than 6 miles an hour. So I would say A or D, because we can see it's the steepest. 6 miles an hour. All right, what's number 7 give for us here? Using the graph, determine the interval in which she was running the slowest. Well, that depends on how you want to answer it. Because C and E, she wasn't running at all. So is that when she's running the slowest? Depends on how you want to interpret that. She wasn't running at all. But as far as the smallest slope, B is slowest when she was running. So I could take an argument for B, C, or E right there. Because B is only ran 3 miles an hour. All the other times she ran more than 3 miles per hour. All right, and our last page here. Determine the intervals over which she was resting. Okay, there's the last one. There's the resting ones. So looking at that question, then this one's definitely B. And she was resting at C and E. She had 2 intervals where she was not running at all. She was resting or taking a poop or whatever she needed to do. But she was definitely not moving, running. Her distance stayed exactly the same for half an hour. All right. Great job, everyone. That was the last page of that. Understanding rates of change, and that's all constant rates of change. They just vary. So let me go back to our lesson for this week. Did the Desmos activity. There's a sample solution of the Desmos activity. This is normally in color, so this doesn't do us any good on my printout. But in Google Classroom, it has the green and the red and the purple. So here's another practice activity for you. We won't do this one in class because I've got the answers here in your lesson. But it says you take public transportation from a stop near your home to a park. So this is distance from home. So you see you start at 0, you start at home, you travel a little distance, you go away, you're at the park, and then the distance from your home gets smaller until it gets back to 0. So that means you're back at your home. The park is about 3.4 miles away. See right here, we're 3.4 miles away from our house. Your trip takes 19 minutes, approximately. You started here at 10 and got there about 19 minutes later when you got on the bus. This represents the number of minutes since you started your trip because you walked for a little ways. You sat waiting for the bus because there was no change in distance. And the bus came. This is obviously some stops the bus made to pick up more people because your distance did not change there for a minute or two. Well, the bus was loading more people on the way home when the bus stopped again, let people off. So this asks 3 questions. Identify an interval of time over which the rate of change is positive. And explain what that means in the situation. Identify an interval of time which the rate of change is negative. And what does that mean? And when it's constant. And so you can do that. Then you can check your answers. On the back, I have answers for those 3 questions. All right. Let's look at lesson 9. Lesson 9 is talking about the average rate of change. We don't always use a linear graph. A linear graph, we can find the slope, right? We can find a positive slope, negative slope, constant slope, a 0 slope. But the average rate of change, I'm going to highlight the word average, is the rate at which one value of a function changes the relationship to the other. Primarily, we're talking about when the x changes, how much does the y change? The average rate of change usually determines the slope of a graph's function. All right, so let's explore this, how we use linear and nonlinear to demonstrate it. So to find the average rate of change, it corresponds to the slope of the line, which connects the 2 endpoints. If we're talking about an average, we just draw a straight line between those 2 points that we're looking at an average between. We don't care what the graph does in the middle. We're talking about the average between 2 points. So the average rate of change is the change in the y divided by the change in the x. Subtract the y's, subtract the x's. Set it up as a fraction. Simplify. Let's turn the page here. I have an example. Okay, so the average rate of change of the function has the change in y values as the numerator, change in x is the denominator. All right, so let's look at one. Since linear functions are always straight lines, their average rate of change will be the same as the slope, no matter what points we select. So if we look at this function, y equals 2x plus 1, if you choose these 2 points, -1, 0, and 0, 2, our average rate of change is we subtract the y's. So our y's are right here, 0 and 2. So 0 minus 2. And then we subtract our x's. Let's put those in orange. -1 and 0. So -1 and -1 minus 0. 0 minus 2. 0 minus 2 is -2. -1 minus 0 is -1. -2 over -1 simplifies to 2. That's the average rate of change between those 2 points, and would be for any 2 points because it's a line. Now, what we know about it right away is we knew the slope would be 2 because this is mx plus b. The m is 2, so that's the slope of the line. So any 2 points we choose, this calculation should always end up 2 because it's a constant rate of change. The rate of change does not change anywhere on the line. Okay, let's go to something a little trickier then. How about nonlinear rate of change? This is when we generally look more in averages because the average of the other one's going to be 2 everywhere. It's a constant rate of change. There's no really an average because everything's going to be 2. But a nonlinear function does not have a constant rate of change, right? The rate of change here is different everywhere. That's a real negative one. It's getting less negative. Now it's 0. Now it's getting positive. Now it's getting more positive, bigger number. It'll have different slope depending on what points we use for average rate of change. So you can find the rate of change by forming a straight line that goes through the 2 points that you want to check. So here, what is the average rate of change between x equals 0 and x equals 1? We make a point where x equals 0. We make a point where x equals 1. We draw a straight line and we find the slope of that line. And that gives us the average rate of change. The rate of change at this part is actually less than what we're calculating. Up here, it's actually very steeper, so it's going to be higher, but the average between those 2 points, 1 minus 3, take the y's, 0 minus 1, negative 2 over negative 1, 2. The slope was 2 between those 2 points on average. Because again, this slope down here is a lot less than 2. This slope up here is a lot higher than 2. But on average, between those 2 points. So, and this would be different. If we use 2 different points, suddenly it's all very different. In fact, if we chose when x equals negative 1 and when x equals 1, we say, okay, if we draw a straight line, so when x equals negative 1 to x equals 1, our average rate of change is 0. It was 3 when we started. It was 3 when we ended. Negative 1, 3. The y's didn't change. So it just depends on what points we use. Same graph, but I found an average rate of 0. This is an average rate of 2. It just depends on where we chose. If we choose a point up here and a point down here, it's going to be a negative number somehow. Because it's going down. The y is going down as the x increases. So average rate of change, you just draw a line and then treat it like it's linear. What's the slope of that line? What's the slope of that line? We can see rise over run, 1, 2 over 1, that's 2. So non-linear rates of change. So when to use the average rate of change formula? Okay, the average rate of change formula is used to find the slope of a graph's function or a table, if you have the data on a table. To find the average rate of change, you divide how much the y changes by how much the x changes. Right, so let's find the average rate of change. It's particularly useful for determining changes in measurable values like average speed, average velocity. Review the following graph of Karen's marathon run. So here's Karen, started out 0 hours, 0 distance. We already looked at this earlier. We found the fastest and when she was resting, but now we know the end was 6.55 hours and 26.2 miles. After marathons, runners often talk about their overall speed. What did she average from here to here? What did she average? We know that we had periods of 0. We know we had periods that she was running 6 miles an hour. You know, but the 0s and the 6s and all this. What was Karen's average rate of change or her average speed for the entire race? Well, we're just going to take and draw that straight line. Take that straight line from up here down to there. What's the slope of that line? All right. What is the average rate of change? This is the 0.00. This is the 655, 26.2. So we take the y's and we can subtract it either way. 0 minus this or this minus 0. 26.2 minus 0 divided by 6.55 minus 0. So that just equals 26.2 divided by 6.55. So our average speed, here I'll put up a calculator. I like how this turned out. I don't want to just do it in my head. I'm going to pull it up here in the calculator so you can see this. 26.2 divided by 6.55 is 4. She averaged 4 miles per hour exactly on the nose. 4 miles per hour. So that was her average speed. So if she can get done faster than 6.55 hours, a little over 6 hours and 30 minutes, a little bit past that, right? Like 6 hours and 33 minutes or something. That will improve her speed of 4 miles per hour. All right. Oh, and here's the answer there. Since she ran 26.2 miles in 6.55, her average is 26.2 divided by 655, or 4 miles per hour. So then I've got the rest of the lesson, and I'm not going to do this in class, but this is for you to look at to see if you understand it. So here's the federal minimum wage in the U.S. from 1980 to 2009. Doesn't have every year. It lists some years, and it puts a blank in 1996. And here's the question, see if you can answer. What was the average rate of change from 1980 to 81? Well, this just went up 1, and that went up 25 cents. So the average rate of change was 25 cents a year, right? 25 cents per hour per year. If the minimum wage increased that rate every year from 81 to 1990, what would it have been in 1990? Obviously, it did not keep going up 25 cents a year, because in 9 years, it's still in the $3 range. But what would it have been if it kept going up 25 cents every year? Use the average rate of change from 91 to 97 to estimate what 96 would be. If it was going up the constant rate between those years, what's the average that goes up every year? 6 years, it went up 90 cents. So you'd have to divide that, 90 by 6. What would 1996 be? And then the minimum wage experienced a substantial increase from 2007 to 2009. Like, it went from 5.85 to 7.25 in just 2 years. Suppose the average rate of change there was used to calculate the minimum wage in 2025. What if it kept going at that rate? What would you expect the minimum wage to be then? So that's some questions to see if you can answer using the table. You got all the X's and Y's there that you need to use the average rate of change formula. On the back, I've got other questions to help you consider after you try to figure your answers on the front. What does the average rate of change tell you? Went from 25 cents from 80 to 81. If this had been applied from 81 to 82, what would it have been? And I give you the answers. So you have the questions and the answers. So, all right. That is all the new information. So that sets you up for this week's lessons, which is the 8 and 9 assignment. When you click on that, take you to formative. And it's got rate of change questions. Formative just takes forever to load these days. I don't know what's this. So it's got rate of change problems right there. Previewing that as a student. Right? Determine if this represents a positive rate of change, negative rate of change, or constant. The number of guests in the amusement park during the last hour of the day. Karen runs a marathon. Still talk about Karen in there. Some of that we've already answered in class. So yeah, coming to class, you got some answers already. Find the average rate of change for this over the interval -1 to 3. So you would take -1, substitute in for X, take 3, substitute in for X, and that'll give you the 2 Y's. So then you got your 2 points that you can use. For the following graph, indicate the interval of increase. This is the graph X equals negative, or that's the axis of symmetry right there. Yes, Cadence, you got a question?
Yes. So on the one where asked at which interval she's running the fastest, can
Yes.
we put A or D and it will be correct?
Should.
Okay.
If not, I'll double check that in a minute, make sure it's grading that correctly, because it doesn't always grade things correctly.
Okay.
This is for this graph, indicate the interval of increase, and you have to type it. So basically, this is like when we looked at the California tides. When's it going up? When's it going down? So in this case, it's anytime X is larger than -2, right? Because when X equals -2, it's right here at the bottom That's when we do it purple. It's not changing at x equals -2. So is it increasing when x is smaller than -2 or x is bigger than -2? So that's what you would type there. And then what is the interval of decrease? So if it's increasing here, when is it decreasing? And that's it, 5 questions. So our lesson's not very long. Our assignment's not very long. And then you have the College Board assignment. Again, there's 10 multiple choice questions. So that's what you have today. You got a 5-point multiple choice question and a 10-point. Well, not all multiple choice on the 5, but 5 simple questions. All rate of change. A lot of that's, we're talking about linear average rate of change. And that's from Algebra 1 even. So this shouldn't be a very tough week. It'll give you a chance to get caught up on some other things if you're behind. But got any questions? I'm happy to answer them. Otherwise, you're good to go, guys.
Let's get out of here. Word to your multiples. Math, baby. We're learning math, baby.